Welcome to Brain Vision.
In this problem, we have a cup of water sitting at room temperature. So we know there is 1 kilogram of water at 20.0 degrees Celsius and a drop of some unknown material weighing 0.500 kilograms that has been heated up using boiling water, which implies it's been heated up to a temperature of 100 degrees Celsius, is going to be dropped into this water. Then we're going to let them sit and equalize temperature. We're told that once they have equalized, we're going to have a combined temperature of the two of 22.0 degrees Celsius. So after 5 minutes. The time's a little arbitrary here since we're assuming no heat has been lost to the environment. So we'll call this T final. Question is, what is the specific heat of the material? This is really just a conservation of energy problem. The heat lost by the material put in should be equal to the heat gained by the water. So we can express that as the heat lost by the material is equal to Cm, specific heat of the material, delta Tm, the change in temperature of the material, times mm, the mass of the material. So this should be equal to the heat gained by the water. So that's going to be Cw times the change in temperature of the water, delta Tw, times the mass of the water, m sub w. I'm also going to add a negative sign over on the left side here to say that it's the heat lost by the water. So now all we have to do is solve this. We can say that the specific heat of the material should be equal to the specific heat of the water, change in temperature of the water, mass of the water, divided by negative change in temperature of the material times the mass of the material. We have all these numbers. The specific heat of water is known, so you can just Google that. We'll find that this is equal to 4,186 joules per kilogram degree Celsius. That's specific heat of water, times the change in temperature, went from 20 degrees to 22 degrees. So that's just going to be 2.0 degrees Celsius. And then we also have the mass of the water given as 1 kilogram. It's going to be 1.00 kilograms. Dividing by the negative change in temperature of the water, we're going from 100 to 22, so the change in temperature was 78 degrees, but that is negative 78 degrees, so the double negative gives us a positive. So we can say the change in the temperature of the water was 78 degrees Celsius times the mass of that material, which is given as 0.500 kilograms. Plugging all of this into a calculator, we will find that the specific heat of the material is 215 joules per kilogram degree Celsius. Part B of the question asks us, which is a better material for storing energy, the water or the material? So the idea here is you want to be able to put in a lot of energy into a small quantity. That makes a better storage material. So because the same amount of heat put in makes the water heat change temperature by a smaller amount, it means that the water is a better storage of material. So part B, we can say that water stores heat better. Part C asks us, if the system had not been ideal and heat had been lost to the environment, how would our answer to part A change? So the idea here is that if we had lost heat to the surrounding environment, the final temperature would have been lower, say 21 degrees instead of 22. So if we were to look at that, how that affects the equation, that would mean the change in temperature of the water would have been less. The change in the temperature of the metal would have been more. And looking, we see that the change in temperature of the water is on top of the equation. and the change in temperature of the material is on the bottom of the equation. So given that, that would imply that we would get a smaller answer, so we would find a smaller specific heat for the unknown material.